All right, guys, let's look at some of the homeworks from 5.2. So I assigned two of these here, 5y double prime plus 4y prime. I said 5 and I mean 4. Plus 10y, 0. There was no initial condition, so we need to find the general solution here. It's exactly what the title says. It's homogeneous, it's linear, and it is constant coefficients. So we know what to do. So step 1 is find the characteristic equation. Make sure that you know how to get this characteristic equation, right? So also be a bit on the lookout if they would try to fool you and put the y double prime in the back instead of in the front or so. You always be careful, right? Okay, so this is our equation and we have to solve this. Well, the problem is sometimes should we try to factor or not? I pointed out to you there's a factorization method for this kind of thing. It's when a is not 1, but is you take the product, the AC method, you take the product of a and c, 40, and you try to find two numbers that multiply to 40 and add it up to 4. But you can try a little bit, but 5 and 8, that's the closest you get, but the difference is you don't get to 4, right? So it doesn't seem to work. That doesn't mean that it's not possible to solve it with factoring, but it kind of starts saying, oh, okay, I don't see it right away, so let's jump to the quadratic formula. The quadratic formula is never wrong, right? It's just a bit tedious formula. So, okay, let's see. What is the... It is minus b plus minus square root... Write it up one more time. b squared minus 4ac over 2a. Okay. So b squared, that is 16, and now we have to subtract 4 times ac. That's 4 times 40, that is 160. Okay, divided by 4 times, that is 8. Okay, so we see, okay, why we couldn't factor it, because we do get a negative. The 160 is way bigger than the 16, right? So we get minus 144. Yes, okay, over 8. Then we shouldn't leave the negative sign inside the radical. We really should write it as a real number this way, and then we see immediately what is happening, right? Because 144, that is actually 12. The square root of 12, 144 is the square of 12. So we have minus 4 plus a minus 12i divided by 8, and we can even, because we need to know what the real part is and what the imaginary part is, so let's work it out. Minus 4 divided by 8, that's minus a half, plus or minus, and then 12 divided by 8, we can simplify, that is 3/2 I. So what does this mean? This means this is what we called lambda during the lecture, and this is what we called omega. So we know now that the general solution, so this is step 2, the general solution is a times e. So this, what do we do with the lambda? That becomes the coefficient instead of for the power of e, and the 3/2 becomes the coefficient inside the sine and cosine. Sorry, sine 3/2 x plus b. Oh, yeah, I could have factored that. Sorry, let me write it a little bit more compact, because that is what they do in the book too. So because both solutions have this e minus x2 in there, and then we have a times sine 3/2 plus 3/2 x plus b times cosine 3/2 x. That's the general solution, and that's it. There's no initial condition, so we stop here. You might say, what do we do if this is a negative number? Well, it is always plus or minus. So you always take the positive one. But there's nothing wrong if you take the negative one. It's still correct, because if you have a negative sign here, what happens? The sign of a negative number is minus. But that's, we have this constant that kind of absorbs that minus 1. And the cosine is an even function where we write here minus or plus, it gives the same result. So we don't change this general solution. Okay. That was number 11. And then number 15, this was an initial condition. That's 6y prime plus y prime minus y equals 0. And we had y0 is 10. and the derivative at 0 was supposed to be 3. Oh, no, but 3, this is supposed to be minus 1, sorry. Let me see that I'm reading the right question here, yeah. Okay, so step 1, the characteristic equation. Okay, that's 6t squared plus t minus 1 equals 0. Again, okay, it's not the nicest form, but I would always try the AC method before you go to quadratic formula. So here we have AC would be 8a, 6, c is negative 1, so negative 6. So we need, and b is 1. So the AC and b here refer to the coefficients of in the standard form of the quadratic, right? It's not the a and b that we have later on. So what is it now? So we need two numbers that multiply to negative 6 and add up to 5. But that is actually possible. That is plus 3 minus 2, because that is 3 times negative 2, right? That's negative 6. What do we do with that? So we replace, this is the one that we use, so ct squared, and we write 1 as 3 minus 2t minus 1, so it is 6t squared plus 3t minus 2t minus 1. And then we group. So this is always the same, right? We haven't changed anything. The first two we can factor out to 3t. That is 2t plus 1. And here we can factor out the minus 1, 2t plus 1. So we can combine. There's a 2t plus 1 that we can factor out now. So 2t plus 1. And what is left is a 3t minus 1. And now we see that if we put this equal to 0, then t equals 1/3. If we put this equal to 0, t equals minus 1/2. So what are we dealing with? Which case are we? So this is the case of two rule of the discriminant is positive, right? So this we know that this means, and in step 2, that the general solution will be given by exponentials with those as coefficients. So e x over 3 plus b e to the minus x over 2. And again, the order in which you write this is not important. But there is an initial condition, so step 3. If x is 0, then y was negative 1, and the derivative was 3, I believe, yes, 3. So the first two we can just plug in. So we see if I plug this in, let's do this here. If I plug in, then I get minus 1 equals a plus b. We have seen this now several times, right? Why this is so simple. But we have to also take the derivative. So what's the derivative here? Y prime is 1/3 a e x3. The 1/3 comes from the chain rule. Minus 1/2 b e to the minus x over 2. So if I plug in now, x is 0 and then y prime is 3. So I get 3 equals. This gives me 1/3 of a. This gives me minus 1/2 b. And there we are. We can get rid of the denominator by multiply with 6. So we get 18 is 2a minus 3b. And the other one was minus a is a plus b. Okay. And so now we can do some elimination. Since I have actually never shown yet substitution, let me remind you how that works. Especially when one of the variables has no coefficient in front of it. I mean, it's just a coefficient 1 in front of it, then it's easy. Like, for instance, in this equation, we can solve for a. So a is then equal to minus 1 minus b. And then you plug that into this equation. So get 18 is 2 times minus 1 minus b minus 3b. So we get minus 2 minus 2b minus 3b. That is minus 2 minus 5b. Bring the minus to the other side, I get 20 equals minus 5b, and then I see that b is 20 divided by minus 5, which is negative 4. And once I have that, I can plug it in already in this form. It makes it easy, right? Then we see that a is minus 1 minus minus 4. Be careful, that is 4 minus 1, that is 3. So our solution is, y is the solution. Y is 3 times e x divided by 3 minus 5 times e minus x over 2. That's our solution. So this is rather simple, right? But we'll see now what happens if you don't, when you have non-homogeneous.